Chapter 6, Association between quantitative variables. In the last video, we saw association between categorical variables. As with quantitative variables, we saw summary statistics. There are so many ways in which you can do lots of things with quantitative variables. Similarly, even an association between quantitative variables is much more richer. So let's get into it. We saw an example last time. Let's say we want to find out where should be my next new store so that I can maximize the sales, or what will be my electricity bill for the winter that's coming, and we know the forecast of the weather. What will be my electricity bill? If you want to get that kind of association, or even like what would be my cost of insurance given my age, all of those things are quantitative, right? The age is quantitative, cost is quantitative, sales is quantitative. So when you have this quantitative data, you want to use statistics and association rules that apply to quantitative data. And the way you like we saw in categorical data, we use scatter plots. A scatter plot looks like this, where there is an x-axis and there's a y-axis, and for a given x, you're trying to predict y. And so there are these data points that you plot, and typically there is some pattern. As you can see, there's a pattern here that, hey, let's take this example which says, hey, how much is the let's say here, we're going to take distance and sales. So if my distance increases, my sales is also increasing. Distance from my nearest competitor, right? So if I'm trying to build a new store and I want to find out where should it be, so what I find out potentially is that, hey, the distance from the nearest competitor and my sales, if I'm going to do this, then I'll probably find out, hey, that there's a pattern here. You can see that there's this line that you can see a pattern here, and there's a histogram that you can plot at the top of your x-axis and then also of your y-axis, right? So scatter plot is the way to go when it comes to association between quantitative variables. And a visual test is highly recommended when you do association between quantitative variables, because you might find associations to be weak, but a visual test will quickly tell you whether, hey, is this even in the right ballpark? So there are, very quickly you can see that, hey, if there is a strong concentration, if you see this one, if the line has strong concentration around it, then the correlation or the association is going to be strong. And if it's also strong but it's going downwards, then the correlation is negative. So let's get into what is covariance and correlation, and then we'll come back to the visual test. So like we did in Kramer-Sui and covariance, right? We have covariance and correlation here. Covariance is basically how far are my data points away from the mean, right? So if I were to draw a hypothetical diagonal, for the y bar and the x bar, how far are these data points from the mean, right? Like this is my point. Let's say if I take this point, then I'm going to find the distance here, and for this point I'm going to find this distance. So basically it's a degree of data concentration along the diagonal of the scatter plot, and you find out the covariance between x and y is for a given data point. You find out the difference from it and the mean multiplied by the y-axis difference from it from the mean of that, and then you keep doing that, and then you find the covariance between x and y. And covariance again is like a large number. Covariance actually brings that down from -1 to +1. Covariance of -1 means a strong negative. Correlation of -1 means a strong negative correlation. Correlation of +1 means strong positive correlation. So means if x goes up, y goes up. That is positive correlation. If x goes down, y goes up. That's a strong negative correlation. It's like opposite. So either end is a strong correlation. When you minus 0.75 to -1, minus 0.75 to 1 is moderate. 0.5 and below is very little correlation, and then below is like hardly any correlation. So you see how we can convert covariance into correlation. Once you do that, you can find out the degree of association. that you can use here. See, this is correlation of R of 0.95. It's a strong straight line. The points are connected very close to the line, and minus 0.95 correlation is a strong negative correlation. One variable goes down, the other goes up. And then there is a nonlinear correlation, and there's, the distribution of points are probably going to be much more spread out. Then it's like 0.75, and then for 0.5 it's like the points are spread out even more, but there's still a pattern. So from when you see this visually, you can find out like how correlated they are, but you can also draw a line, a correlation line, and you can do that with this formula. Y bar, which is what you're trying to predict, is the mean minus b times x bar. B is the coordinate when y equals 0, right? What is the x-intercept? And then r, which is correlation, times standard deviation of y, standard deviation of x times x. So basically, all of this, we don't have to really understand how this works, but basically you can think about this as how far off are they spread out from the two diagonals. That was a really good understanding for me conceptually to understand. It's trying to find out how far off they are. If they are not far off, then the correlation is stronger, but if they are too far off, then the correlation is weaker. And there are tools available that can easily make these lines for you, but we can create them for ourselves as well. Once you create this line, you can actually plot, saying, hey, there's this correlation line. And so then you can easily predict, like even for some new random variable, like, hey, if this was my x, what will be my y, right? So this allows you to predict. Once you create this line, now you can plot anywhere, and you can say, hey, given the winter temperature, I can then easily predict the electricity bill. Given the distance, I can predict the sales. Given the age, I can predict the cost of insurance. Now see how we got very quickly from plotting the data to finding that regression line, finding that correlation line, and then using that line as a basis to say, from all the data that I have, I think this is what's gonna be the predicted outcome, which is very powerful. But there is 4 things you need to be aware of before you conclude with saying, hey, this is what's gonna happen. So the checklist is, you have to ensure that there's no lurking variables or there's no spurious correlation. So you really have to understand the domain. You can't say, for example, that, hey, math skills is going up because shoe size is going up, or that there's more people dying due to suicide because of summer heat. No, there's a third variable. Shoe size and math skills, the much closer variable is the age. The age goes up, shoe size goes up, math skills goes up. But there is an association, but not a causation between the two. Similarly, summer going up makes summer temperatures going up makes people go to the swimming pool, and so they die from drowning. I said suicide, but it's dying through drowning. So basically, this is the third variable. We try to associate variables that are not really related. So make sure that there is no spurious correlation, or that there's no lurking variables. And the way you do that is you really understand the context. You understand the domain that you're in. Second, this technique only applies to quantitative data, not to categorical data. We have a very different technique for categorical data. Very similar lines, but the way you do it is different. And then you have to have a visual test, because there may be a lower correlation, but there could be a non-linear correlation, right? And you might have to look at your data and your scatter plot with your visual test to see if there's outliers in there, and you want to do it with or without the outliers, so that you can actually see how your predictions are with and without the outlier. And in Excel, all of this can be done easily with your data analysis package, and you can create a correlation matrix, and it doesn't even have to be 1 or 2 variables. Excel can do it for n number of variables. There are many such data packages that give you correlation between multiple variables. So it's very important to understand that scatter plots is important, how we predict, how we go from predicting, and how we use a correlation from -1 to 1 to actually give a very clear understanding of what the strength of the association is for quantitative data. Thanks.